All right, so today we're going to be talking about section 1.1c. Last part of 1.1, we made it. I just have some examples for you today. I'm done going over vocabulary and how to name things. For today, we're just going to be working some examples, how to apply that information we've been talking about. So here's your first example. Draw and label a figure for each relationship. So it says plane P contains lines M and N that intersect at R. So first let's look at this. I'm just going to go one part at a time. Plane P. Well, I know how to draw a plane. We've been talking about that. Here is my plane. And it's called plane P. So it's super important to name your stuff. If it has a name, you need to name it. So this plane's name is P. And so I'm going to put that P in just a corner somewhere. It's going to hang out there. Plane P. All right, moving on. It contains. So let's think about that. Contains. Is it on the plane or outside of the plane? Well, if it contains, it's in the plane. It contains two lines, M and N. So let's back up. If it's a line, does that mean it goes on forever or does it start and stop? Well, a line goes on forever. So I'm going to draw two lines. I've read ahead, so I know that my lines intersect. So I'm going to go ahead and draw them that way. So there's my two lines, and they intersect. So I'm going to label one of those lines as M, and the other line is N, and it says they intersect at R. Okay, well, hello, it doesn't tell me what R is. Remember, we talked about in 1.1a that points are just named with capital letters. I don't have to tell you it's a point. If it's a capital letter, that's me telling you that it's a point. So they're going to intersect at a point, and that point's name is R. Okay, simple enough. Now let's look at the next one. This example is pretty similar. Draw and label a figure. Plane R contains lines A, B, and D, E, which intersect. So again, I'm going to draw them to intersect to cross each other at point P. So that sounds pretty similar to what we just did. Here's the difference. Add point C on plane R so that it is not collinear with A, B, or D. All right, so we're throwing in a lot of vocabulary, a lot of symbols into this. So here goes. I'm going to start by drawing my plane. And this plane's name is R. All right, it contains lines A, B, and D, E, which intersect. So I'm going to go ahead and do that. Here's one line. Here is another line, and they intersect. So one of the line's names is AB. So remember, a line is named by any 2 points on that line. It doesn't necessarily mean it's right there at the end. You can pick wherever you want to put your 2 points. So there's A, here's B, and the other line's name is DE. DE. All right, let's keep reading. They intersect at point P. I think that's the easy part. Well, these lines clearly intersect right here. That means that point's name is P. All right, add point C on plane R so that it's not collinear with either one of those lines. Okay, so collinear, not collinear. So not co together, linear line. So not together on the same line. I want to put C somewhere where it's not going to be on either one of those lines. All done. All right, look at the next one. This is the part of the video where you should probably be going, oh my goodness, Miss Parsons, this is so simple. This is it right here, okay? So if a point is between two other points on a line, addition or subtraction can be used to find the missing measure. Okay, so maybe you're not quite there yet, but this is what that means. Here's what I just read. Find the measure of each segment. It wants me to find LM. It wants me to find this distance. It told me the whole distance is 4. This distance is 2.6. Should I add or subtract those? Obviously, I'm going to subtract them. I've got the whole part. I'm going to take away what I've got. And that leaves me with 1.4. So LM, line segment LM, is 1.4 centimeters. Okay. Again, that's the one, like, I could have left off this part, and I think that you could have told me exactly what to do. Okay, so if a point is between two other points on a line, you're going to add or subtract to find the missing information. All right, moving on. Got a couple more examples for you. Look at this one. So here goes that betweenness stuff again. This problem just doesn't have a picture. So it says find x and st if t is between s and u. Okay, I'm going to stop reading right there. Find x and st if t is between s and u. So I'm going to draw a line. I don't know if this is a line. I don't know if this is a line segment. It doesn't tell me, but I know I've got some points, t, s, and u, and I know that t is between s and u. I'm going to draw mine as a line because I don't know. It doesn't matter. Yours can be a line segment. And I know that t is somewhere between s and u. Notice I didn't put t right in the middle. It doesn't tell me t is in the middle of s and u. It says t is between s and u. So there's my picture. I highly suggest in geometry, anytime you have a problem without a picture, that you draw a picture. All right, I'm going to label what I know. It says that st is 7x. That's this distance right here. su, so the whole thing, is 45. And we know that tu is 5x minus 3. Now that I have a picture, I hope that when you're looking at that, you're going, oh, I know what to do. And so when you look at this, I've given you the whole thing and I've given you two parts. So hopefully when you see that, you're wanting to write an equation, you're wanting to put those two things together so you can figure out what x is. I know if I take this one part and add it to my other part, it has to equal the whole thing. I'll let you look at that for just a second. Those two parts, if I add them together, they have to equal the whole thing. Now I just have a simple equation to solve. Now I know you haven't solved an equation in a while, but I think you can handle this one. So we've got 12x minus 3 equals 45. 12x equals 48. Then my last step, divide by 12, x is 4. All right. Also in geometry, it's super important that you're reading the directions. So I'm going to go back and read the directions of this problem. I want to make sure I actually solved it. So it says find x and st. Super important. Find x, found x, but and I need to find st. I know from reading the problem that st is equal to 7x. Well, x is 4. So st, by doing a little substitution, must be 28. All right. All right, check this out. Congruent. I bet you've heard this word before. If something is congruent, it means they're equal. They are the same. This is the symbol for congruent. Super important. I'm never going to write out the word congruent. You're going to see me use this symbol a whole lot, though. Okay. So when you look at this picture, you can see that PS is 5, and so is QR. That means that PS is congruent to QR. You'll also see sometimes when you're working a problem, these little tick marks that go through the sides. That's me letting you know that those two sides have the same measure. Okay, I can do something that simple, just those little marks, and then letting you know that, hey, those two things, they're the same. Okay, so we don't ever assume anything in geometry. I've got to tell you they're the same. They've got to have the same measure. Something like that has to happen. All right, two more examples. So here's a definition for you. The point on a segment that divides the segment into two equal segments is called the midpoint. I think you could have figured that one out without me telling you to. Let's break that word apart. Midpoint. It's obviously going to be the point that's in the middle. Okay, so I do want to draw a picture of that for you. Here's a segment. I'm going to call my segment XZ. The midpoint is going to be this point in the middle. Now, don't get too carried away though. When you look at this picture, some of you are going to jump straight to, well, why is the midpoint of XZ? Do I know that for sure? Like, am I positive when I look at this picture? No, I didn't use a ruler. I didn't measure that. I don't know that. But the way I can know it is from these little marks. Remember, I just told you those little marks mean congruent. So now that I've put those marks in it, I know for sure that since these are two equal segments, y must be in the middle, meaning y is the midpoint of xz. All right, last thing. So similarly to midpoint, we have something called a bisector. A bisector is a little bit different, though, in that it's not a point that divides a figure, but it's another figure that divides a figure into equal parts. And so my favorite example to use for this one is I've got this line segment. This time we'll use AC. And on my last example, it was midpoint. So there was a point that cut this line segment in half. Now it's going to be something else. It could be another line segment. It could be a ray. It could be a line. It can be any of those things, but it's going to cut it in half. It's going to hit that middle point. So I'm going to use a line for this one. Why not? And I'm going to call that line L. And I'm going to put a point right here just for fun. There's point B. Okay, so a lot of you, again, are going to look at this and you're going to tell me that line L bisects AC, line segment AC. Remember, that's only a valid statement if you know for sure. Do you know for sure that line L has cut this segment in half? I'm going to know for sure if I add these marks, or if I told you that this was 3 centimeters and this was 3 centimeters. So now this is a valid statement. Line L bisects segment AC. All right, that's all for 1.1.